You're given the question, express x plus 4 divided by x multiplied by x plus 1 multiplied by x plus 2 in partial fractions. Hence, find the sum of the series 5 over 1 times 2 times 3 plus 6 divided by 2 times 3 times 4 plus 7 divided by 3 times 4 times 5 plus dot 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 plus n plus 4 divided by n multiplied by n plus 1 multiplied by n plus 2. And you are required to show that the series is convergent and state the sum to infinity. So the first thing to do is to split the question into simpler sections. This is the first thing you have to do. Express x plus 4 over x, x plus 1, x plus 2 in partial fractions. So when you're asked to require to do partial fraction, you would let it equal, you do the a plus b plus c thing. A divided by x plus over like this, and then you find the numbers. You multiply both sides by this, so you'll get x plus 4 equals to a x plus 1 x plus 2 plus b x plus 2 plus c x plus 1. Okay, then now you want to find, let's say, the method. What is the value of a? So you let x equal to 0, so you can cancel out b and c. So let x equals to 0. So 0 plus 4 is 4. Then a 0 plus 1, 0 plus 2 equals to 2a. Then b times 0 is just 0, so you cancel out the whole thing. C times 0 is also 0, so you can cancel out the whole thing. So you're left with 4 equals to 2a. So you simplify it and find a equals to 2. Now, you want to find b. So you let x equals to, how can you cancel out a and c? You let it equal to -1, right? Because -1 plus 1, -1 plus 1 equal to 0. So you cancel out these two. So -1. So -1 plus 4 is 3 equals to negative b, -1 plus 2. Then this one's cancelled out. So you have 3 equal to 2 minus 1 is 1. So you get negative b. And b is -3. Now to find c, you need to let x equals to -2. Because -2 plus 2 is 0. So you can cancel out these two. So let x equals to -2. So -2 plus 4 is 2. Then -2c minus 2 plus 1. So 2 equals to -2 plus 1 is -1. The -1 multiplied by -2 is 2. So you get 2c, and c equals to 1. So now you find all three of your values of a, b, and c. Now you can change this into a partial fraction. So you rewrite it down. X plus 4 over x plus 1, x plus 2 equals to a is 2 over x, and b is -3, so I'll just bring the negative down to here. So -3 over x plus 1 and plus 1 over x plus 2. So this is your partial fraction. So you've completed the first part of the question. Now you want to find the sum of the series of this. So you know, by comparing from this to this, you can tell that the last term of this series is n, because every single thing is the same except x and n. And if you compare these two together, 5 equals to x plus 4. So you'll find that this here, x equals to 1. So that means this is the first term in the series. So the question wants you to find the sum of the first to the nth term. So you can write that down. And the summation sign. And r equals to 1. And then you rewrite this. You write this thing. X plus 4. Wait, no. You write r plus 4 over r plus 1, r plus 2. You change all the x into r's because you wrote here, because I've written here r. And then you simplify this into your partial fractions. So equals to n sum r equals 1 in 2 over r minus 3 over r plus 1 plus 1 over r plus 2. So now you have this. How would you want to solve it so you can find the sum of this from the first term to the nth term? You can split it into simple functions by replacing this into a function, this into a function, and this into a function. So I'll be using function f. So fr, I'll choose the simplest one here, which is 2 over r. So fr, I let fr equals 2 over r. Let fr equals 2 over r. Now, how can I change this so that the denominator is the same as this, r plus 1? It'll be plus 1, right? So fr plus 1 equals to 2 over r plus 1. Just like that. So now I just keep it like this. Now I rewrite this again. And sum r equals to 1. And I use the values here to rewrite it. So 2 over r. Then since this here is minus, so I'll minus this one. Minus 2 over r plus 1. Now, this minus this equals to negative 1 over r plus 1, right? So I'll write that minus 1 over r plus 1. And then I just rewrite this as normal. Plus 1 over r plus 2. Now let me substitute this with the two functions so it's easier to look at. Alright, so this is a method of differences. So this minus this, that is a difference. Now, so these two also minus each other, right? Got negative and positive. So let me rearrange it so that it's minusing each other. Alright, so now it's this minus this. So I want to change this into a function as well, but a different function. I'll use the letter G, or you can use any other letter if you like. So let me rewrite that here. Okay. So I let gr equals to, I can pick either one of this as my gr. I'll pick the second one because it's a smaller value. You can use this also if you want. Okay. So how can I change this so that it becomes r plus 2? I plus 1, right? So g r plus 1 equals to 1 over r plus 1 plus 1, which equals to 1 over r plus 2. So now this the denominator of both of them are the same. And the numerator also exactly the same. So that's better. So I'll rewrite the whole thing again, but with function g in it. Just like that. This one, the FR comes first because that was the original arrangement. So this one is the same as that. So you're right. So I write GR plus 1 first before GR. Okay. So from here, I can substitute. I can already open up the bracket to find my answer. With this method, you take the smallest term here, which is the first term, and you replace it into the smaller value of the respective functions. So for function f, the smaller value would be r, because r is smaller than r plus 1, right? That's common sense. So fr plus fr1, I just replace the value. And then for this one here, the smaller one would be r as well. So it will be minus g1. And then the value on the top, the biggest value, which is n, you place it into the bigger values. So it will be f n plus 1. Just like that. All right. So from here, you then replace that into the original one of this one and this one. So you'll get f1 is 2 over 1, then minus, this one is n, so 2 over n plus 1, then plus the g1, it would be 1 over n plus 2, then minus g1 is 1 over 1 plus 1. Simplify that, 2 minus 1 over 2 minus 2 over n plus 1 plus 1 over n plus 2. Then I simplify further, 3 over 2 minus 2 over 1 plus 1, n plus 1 plus 1 over n plus 2. Alright, and that is the final answer for the summation of the series. You can simplify it further into a single fraction, but it's perfectly fine to leave it like this. Okay, so the second part of this question is finished. Now the last one, it asks you to show that the series of this is convergent and state sum to infinity. So to find whether this series is convergent or not, you let the limit of the function n as it approaches to infinity. Then you write down the equation, this one, 3 over 2 minus 2 over n plus 1 plus 1 over n plus 2. Alright, then now if you think about it, when n is replaced with infinity, 2 divided by infinity plus 1 would be 0, right? Same goes to this. 1 over infinity plus 2 is 0. So your answer would be 3 over 2. So this series is convergent. Since it has a specific value when n is infinity. So now that you know it's convergent, we can find the sum to infinity. Because if this was divergent, the sum to infinity would also be infinity. So the sum to infinity would equal to 3 over 2. And that's how you do this question.